problem. So see if you can solve it. Okay. And those of you who already solved this problem, try this type of a problem as well. Okay. This is yet another problem of that type. But for most of you, try to solve some of these problems. Okay. Yeah, try this problem. I'm not going to give you the next problem until I see more people responding. Looks like this is a slightly complicated problem here. So what are they saying, right? They're saying that if the twice the radius, right? And remember, we've done this before, twice the radius. What does it mean? If the radius, so always think about it like this. Always take these numbers to be 1 and 1, okay? Very simple. So originally, let's say you got a cylinder, right? You had a cylinder with radius 1. Radius was 1, and the height was also 1, okay? So what is the volume of this, guys? Then in that case, the volume would be pi times 1 squared, right? Radius is 1 squared times 1, right? It's going to be equal to pi, right? It's going to be equal to pi. Now try to solve this problem and see if you can understand it. So they're saying, what is the volume in cubic centimeters, right? And ignore this piece for now. Just think about it this way, right? So what is the volume in cubic centimeters with twice the radius and half the height? So what happens? You start with this radius and you now double it. That's what they're saying. Now remember, if you were to start with 1, it would become 2, right? It would become 2. The new radius would become 2. Well done, Suraj. Yes, this will become 2, and the height would become half. The height would become half, right? That's the benefit. That's the shortcut. That's the hack for this, okay? So this radius is doubled and the height is halved. So you can do this for every single problem of this type where they say, oh, this guy's halved, this guy's doubled, this guy's tripled, this guy's become 20 times. Doesn't matter. Always start with everything as 1. Everything should be 1 and then work off of it, right? So now what do? So the new volume, I'm just going to call it new, is equal to, I'm just going to use this formula, guys. I'm going to use pi times 2 squared now because the new radius is 2 squared, right? And the height is half. Right? So what happened over here? Let me use a different ink, right? Let me use a different ink here. So you used 2 squared times a half, right? That's your new volume. Now, so that's going to be pi times 4. 2 squared is 4 times half, right? Now 4 times half is 2, so you're going to write down 2 pi, right? Because pi times 2, you got 2 pi, right? Now you compare this guy with this guy. Don't worry about the 22 cubic centimeters right now. Don't worry about it. That's meant to confuse you, okay? Yes, it's meant to confuse you. That's the goal of this test, right? It's meant to confuse you, but you need to know the various pieces where you can be confused and then say, oh, I know this. All the little traps, right? You should be able to jump over them. All of those traps, you should be able to jump. You should be able to identify all of those little traps, right? So yeah, so what was pi becomes 2 pi, right? What does it mean? That the volume is basically doubled, right? The volume has doubled. All of this information is just telling you the volume has doubled. So if the original volume was 22, right? If the original volume was 22, now it became 44, right? Because it doubled. That's why this is the correct answer, okay? So we're pretty much getting towards the end of the session, right? Let's try one quick problem and I'll show you a hack on that. Let's see what we can do over here. All right, try to solve this problem. Okay, it's a unit conversion problem, right? So hopefully this was a good one, right? Like, yeah, type over if you liked it, or if you like something else, let me know. Did you like the session? How was it, guys? Was it fun? Was it enjoyable? Great, thanks, Loco. Yes, thank you. Thanks, Gurmag. Thanks, CG. Yes, great. Great, thanks, Shiv. Yes, so yeah, we do these sessions. Remember, otherwise you're gonna do your problems by yourself and you're gonna get distracted, right? This way, thanks, Genevieve. Yes, so for sure, right? All of this, there's a lot of, thanks, Ben. All of these problems, right? All of these problems are, I'm gonna show you these problems. So that's in this 20-hour SAT boot camp, right? Remember, you can join anytime. The next session is going to be on Monday at 8:30, and we're going to look at the massive this linear equations problems. Okay, this section is so important. Linear equations, it accounts for 30% of the SAT test. Thanks, Prajita. Yes, it accounts for 30%. It's got so many questions. I'm gonna explain to you every single one of them, and then we're gonna do practice sessions, right? So 1 hour of explanation, then some practice for you, then more practice for you through these kind of practice sessions, hands-on practice, and then you get more problems to practice for yourself, right? And if you want more practice tests in addition to the 10 practice tests, tell me. I've got 40 practice tests, okay? There are more tests than what's on the College Board website, okay? And that's publicly available, okay? Okay, give me 1 second. So yeah, try this problem, guys. So how do you do this one? Well done, well done. So what are you going to do here? For those of you who are having difficulty, I'm going to show you a shortcut, okay? So after you're done solving, I'm going to show you a shortcut on how to think about it, okay? One, I'm going to change the ink a bit over here. Okay, so you're given, guys, you are given, I'm going to move this as well so we can have more space to talk about all of this. Okay, so remember, this was a nice hack, right? This was a shortcut, right? Anytime you're given this, you can solve this problem, right? Now I'm going to show you